Hello dear students, good morning everyone. This is the revision lecture related to class 9 physics regarding periodic third. And in this revision lecture today we will revise all the terms related to force and laws of motion chapter. Force and laws of motion. Just starting from force. Force, mainly the definition concept of force, that is very easy, push or pull. But in exact way, what is the definition? The definition is what? Very easy. The time rate of change of momentum. The time rate of change of momentum of a moving body is defined as force. Clear? Let's see. The time rate of change of momentum. The time rate of change of momentum of a moving body. Of a moving body is defined as force. Here, very easy concept of definition, and the formula concept, that is F is equal to ma. Force, that is represented by F, and mass, that is m of the given body, and a is the acceleration, and its SI unit. SI unit of force. SI unit of force is equal to what? Newton. Where 1 Newton is equal to 1 kg meter per second square. 1 Newton is equal to 1 kg per meter second, kg meter per second square, because kilogram for mass and acceleration is what? That is meter per second square unit. Clear? So the CGS unit of force is dyne, where 1 dyne is equal to 1 gram centimeter per second square. Suppose a question is asking between the relationship between force unit, that is SI unit, and CGS unit, that is dyne, and in Newton SI unit. So what is the relationship between Newton and dyne? Then you will write down what? 1 Newton is equal to this value, and kilogram changing into gram, and meter changing into centimeter. In kilogram 1000 gram, in meter 100 centimeter. 1000 into 100 means what? 1 lakh. So 10 power 5. 10 power 5 dyne. 1 Newton is equal to 10 power 5 dyne. This is the value of Newton in the terms of dyne. Clear? And then after, the concept of Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. Total 3 laws given by Newton, and all the law, the concept of motion is utilized. So first law, very easy law, that is law of inertia. Another name of Newton's first law, that is what? Law of inertia. Law of inertia, or Newton's first law. Newton's first law. Just listen. Newton's first law, only the statement concept is necessary. What is the statement concept? Just listen one thing about inertia. Inertia means mass dependent quantity. Mass dependent quantity. And inertia of a body that is the inherent property of a body. Inherent, it means internal property of a body by virtue of which it resists any change or it opposes any change. Suppose body is in rest, so wants to remain in rest. It means if you are applying force, then body will oppose the application of force, and body is in motion, then you want to what? Stop, then body opposing the stop condition. And if body moving along same straight line and you want to change the direction, then the body opposes the changing direction concept. Here the three concepts: rest, motion and direction. On behalf of three concepts, there are three types of inertia. Three types of inertia. And why it is said to be inertia law? Because the inertia concept is utilized in the explanation of Newton's first law. Just listen from starting. Newton's first law statement is what? Very simple. According to Newton's first law, when the body is in rest, then wants to remain in rest. Second, and if the body is moving, then wants to remain in moving condition. And if the body is moving along same straight line, then wants to remain in same straight line unless an external force is not applied. Clear? Very simple. Rest, motion, direction. Three concepts of inertia is used in the explanation of Newton's first law, or we say that law of inertia. And Newton's second law is a derivational law. It means here we will derive a formula for force. But in first law there are so many examples. Why the passenger getting jerked backward when the stationary bus starts suddenly, and when the running bus stops suddenly, then why getting jerked forward, and why the passengers are moved towards left when the bus taking to turn towards right. All these terms that is based on the inertia concept, and when you just read about the concept of inertia, then everything will be clear. And then after the inertia or Newton's first law explanation, the next concept is what? Newton's second law. Newton's second law. Let's see. All these terms very easy, just note down one time. Okay, next. Newton's second law. Newton's second law, very easy law. Newton's second law. It is also known as what? Law of force. Law of force. Why it is said to be law of force? Because in the statement of this, the concept of force is hidden. Concept of force is hidden. The Newton's second law concept, just listen. The time rate of change of momentum. The time rate of change of momentum of a moving body is directly proportional to applied force. Clear? So F directly proportional to ddt of P. Here P means what? Momentum, and ddt means rate of change with respect to time. That's why time rate of change of momentum P. Clear? And ddt is the representation having very short change in momentum with respect to short change in time. That gives the concept of force. And when we replace this symbol, then F is equal to K dp upon dt, where K is a proportionality constant. K is a constant. So, but P is equal to mv, we are going momentum is equal to mass into velocity. Mass into velocity, then F is equal to K ddt mv, then m constant term, so taking out km dt of v. This is the rate of change of velocity, or you say that time rate of change of velocity. This one term. Time rate of change of velocity is what? Or we say that in simple way, rate of change of velocity is defined as acceleration. Is defined as acceleration. So F is equal to kma. Here put k is equal to 1, because by experiment the value of k is often 1, then f is equal to ma. F is equal to mass into acceleration. Here force F is equal to ma. By second law we just derived the formula for force, that's why it is also known as law of force. Statement, listen again. The time rate of change of momentum, the time rate of change of momentum is directly proportional to applied force. Proportional means this symbol, and directly means whenever momentum increases then force increases, whenever momentum decreases then force decreases. Clear? So here directly symbol, and time rate, that is ddt. D means that is the very short change representation in momentum and very short change in time. Clear? So the statement, the time rate of change of momentum directly proportional to applied force, and then after this replacing proportional symbol when we are using a constant term k, so p is equal to mv, then here momentum is equal to what? Measurement of momentum, that is mass into velocity. So m constant term further taken out, km, and ddt of v. ddt of v means what? Acceleration. So we finally got the result, but f is equal to ma. And then after Newton's second law, the last one, that is Newton's third law. Just note down now. Newton's third law, very easy law. Only one statement concept is given in your syllabus, and there are so many examples. Newton's third law. Another name, action reaction law. Action reaction law. Action reaction, because in the expression there is a concept of action force and also concept of reaction force. Action force is what? Whatever the value of magnitude of force we are applying on body, that is what? Action force, and we get just obtain the reverse force in reverse direction by the object on itself, that is what? Reaction force. And how? To every action there is always equal and opposite reaction. Equal and opposite reaction. To every action there is always equal and opposite reaction. It means F12 is equal to F21 with negative sign. Clear? This is the force of action, that is force on body 1 due to 2. Suppose here 2 body. This is body 1. This is body 2. This body is applying force on this, and this body applying force on this. The body force, that is F12, that is force on 1 due to 2, that is F12, and force on 2 due to 1, that is F21, and here F21 or F12 both are just opposite direction and equal in magnitude. That's why here equal symbol taken and with negative sign. Clear? This is the action reaction law. Every action there is equal and opposite reaction. There are so many applications of this law. By this law we can walk. When we are walking, then we are applying force on the earth's surface by using our feet, and the earth just apply what? Reaction force. Then we can move. Otherwise we can't walk. Because if there is insufficient value of reaction force, just like slippery area, then we can't move easily. Suppose you are applying force and you didn't what? Get the reaction force. Then whenever action is greater than the reaction, then means what? Unbalanced force. Unbalanced force means what? The person will fall down. Otherwise anything can be happen. So no matter, whenever the action reaction are equal, then we can move properly. Clear? So after this Newton's third law, the next concept is what? Momentum concept. Momentum concept. Momentum concept also very easy. Momentum and conservation of momentum, and then after applications, and then this chapter will be completed. Let's see concept of momentum. Momentum is whenever a body is moving with some velocity, then there is a concept of momentum. And the momentum we can define in other word, a physical quantity which gives the idea or which gives the concept of force, which gives the idea of concept about force, and that is measured by what? Product of mass and velocity. Mass and velocity. So P is equal to mv. It is a vector quantity. That's why I am writing the arrowhead on P and V. Mass is a scalar quantity, but velocity is a vector quantity. It's SI unit, kg, meter per second, or Newton second. There, and CJ will be what? Gram centimeter per second. No matter, you can write down. And when we just plot the graph between m and p, then v constant, clear. And when we plot the graph, P versus V, then m is equal to constant. And the last one, when we plot the graph, mass and velocity, then P is equal to constant. If mass increases, then velocity decreases, and if velocity increases, then mass decreases. Clear? In this way, we can obtain the graph. Very simple concept about the explanation of mass and velocity. Clear? And then after mass and velocity curve and momentum and velocity, mass and momentum, the next one is what? Conservation of momentum. Conservation of momentum concept. Let's see about the conservation of momentum. Conservation of momentum means the total momentum of a moving body. The total momentum of a moving body is always conserved. Is always conserved. I think whenever the body having mass m1 and initial velocity u1, and the final velocity becomes v1, another body having mass m2, initial velocity u2, and final velocity becomes v2, then the total momentum before collision must be total momentum after collision. So regarding to conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Clear? Very simple concept. And application of conservation of momentum, there are so many conservation of momentum applications, and among all, a very important concept, that is recoiling of gun. Recoiling of gun. See, recoiling of gun. What is the concept of recoiling of gun? requiring a gun. About derivation, I just explained all the terms. I am just going here what only one revising the terms. So you have to listen about the concept. What is the concept and what is the basic terms that is required here. In conservation of momentum, you have to use this formula for solving numericals and the derivation concept. If any confusion in previous derivation lecture, then you can ask. Clear? So here the requiring of gun. Suppose just before firing, the bullet and the gun in your hand, and both are in rest condition. That's why their initial velocity becomes what? Will be 0. It means initial momentum, that will be what? 0. And their final momentum, bullet fire with velocity small v, and guns that experiencing what? Backward jerks with a capital V velocity v. Then before momentum, or not before momentum, before firing the total momentum 0, and after firing mv plus capital M capital V. This is the formula concept for requiring of gun. Here 4 terms: small m, small v, capital V. Out of 4 terms, always 3 terms will be given in your numerical, and with the help of 3 terms we can calculate 4 terms. Clear? So the concept of formula: before firing the total momentum of bullet and gun, total momentum of bullet and gun, it means momentum of bullet and momentum gun whenever added then will gives what? 0, because both are in rest condition. And after firing, bullet fired with velocity v, that is small v, and gun requiring velocity means what? Capital V, that is capital M capital V. So after firing, this is the total momentum, and before firing total momentum 0. Clear? So you will try to solve out numerical based on this momentum concept or conservation of momentum concept or Newton's first law, second law, third law, and momentum formula. If any confusion going on, any doubt, or any problem in any numericals, then you can ask. And you are all knowing about my WhatsApp number, then you can send the numericals pic and I will send you the solution with clear explanation. Clear? So that's all for today. Have a nice day.